In this video, we are going to talk about relationships, and we are going to decide if they are proportional or non-proportional. So, before we get started with that, the three ways that we will see relationships are in tables, on a graph, and in an equation. And I'm going to show you here in each of these three ways how to decide if something is proportional. So if it doesn't satisfy whatever we're writing down here, it will be not proportional. And we're going to start out by looking on a graph. So just as a reminder, this is something like a graph. This would be the x-axis and the y-axis. On a graph, to be proportional, the line must be linear, which means it is a straight line, except it cannot be undefined. It must also be a line that goes through the origin, or 0, 0. The origin is right there. So this could be an example of a proportional relationship, a straight linear line through the origin. You might also have something that looks like this. Now let's look at an equation. If the graph has to be linear, then I know that the equation could look like y equals mx plus b. However, the graph must also go through the origin, which means b has to be 0. Because on the origin, if the y-intercept is the origin, then you know that b is 0. So what your equation really looks like is y equals mx, because that needs to be 0. Because proportional relationships are so special, instead of calling it mx, we actually give the slope there a new letter called k. So in an equation, it will look like this. Y equals some number times x. Now in a table, y over x must be the same, which really just means equal in math words, for all points. In 6th and 7th grade, you guys defined proportional as a ratio that was equal, or as ratios that were equal. If all of the ratios were equal, it was proportional. The ratio we're talking about is y over x. That's just the slope. We get y over x by using the equation. If we had y equals kx, and I solved for k, the slope, this would be divide both sides by x. That would make this 1 times k. So you'd have y over x equals k. That's where this comes from. Anyways, these three things will tell us if the relation is proportional. If these things are not true, then the relation is non-proportional. So let's go ahead and look at some examples now. And I will say that all of my proportional relationships are purple, and all of my non-proportional relationships are orange. And we'll start with some equations. So look at the equation, the very first equation right here. I'm going to write y equals mx plus b above it, and I write y equals kx below it. This equation looks like y equals kx because the constant, the plain number, the thing without a variable, is 0. which means this is proportional because it looks like y equals kx. So I color this box purple. Our next equation is in the third row, and it's the third column. I will write y equals mx plus b above the equation, and y equals kx below the equation. Now, this equation has a b value. B is -9, which means this is non-proportional because b should be 0. This is non-proportional. I'll color it yellow, or orange, sorry. Looking at the equation right by it, this would be, I'm comparing y equals mx plus b and y equals kx. This equation looks like mx plus b because b is 7. Since this looks like y equals mx plus b instead of y equals kx, this is proportional. Because the constant is 7 instead of 0, this is proportional. Looking at the next row, there's two equations there. I'm writing y equals mx plus b and y equals kx. Y equals 100x looks like y equals kx because b is 0. There's not a plain constant right there. That means this is proportional, so I'll color this purple. The last equation in that row is y equals 8x. I'm writing y equals mx plus b on top and y equals kx. And now I want to compare this. Y equals 8x looks like y equals kx because there is no extra constant here. There's no plain standalone number, which means that number is 0. So this matches y equals kx instead of y equals mx plus b, which means this is proportional. Looking at the last row, y equals x, I'm going to write y equals mx plus b above it, and y equals kx below it. This equation looks like y equals kx. There's no standalone constant. This one looks a little weird though because it's just y equals x. In front of x there's an invisible 1, so you still have a number for k. Because that looks like y equals kx, this is proportional. So I color purple. Okay, that is all of the equations on this page. Now let's take a look at the graphs. Remember, on a graph, to be proportional, we have a linear, so a straight line that's not undefined, and it must go through the origin. Looking at this graph, I see this does go through the origin. However, this curves, which means it is not linear. Because one of those answers is no, this is non-proportional. Looking at the graphs in the second row, I see this goes through the origin, and this is a linear line because it is a straight line. Since this goes to the origin and is linear, this is proportional. In the next graph, this does not go through the origin. However, this is linear. But because it is not both linear and through the origin, this is non-proportional. And the last graph, I look for two things. I look, does it go through the origin? And it does. And then I look at, is this linear? And it is. Because it goes through the origin and it's linear, this is proportional. Looking at the next couple of graphs. Here I have a graph that goes through the origin, and it is linear. Since it goes through the origin and is also linear, this is proportional. Looking at the graph just below that, this does go through the origin. However, this is very curvy, so it is not linear. Even though it goes through the origin, because this is not linear, this is non-proportional. There's one more graph for us to look at. This graph does not go through the origin, but it is linear because it's a straight line. However, because it is not both linear and going through the origin, this has to be non-proportional. Alright, and the last kind of relationships that we're looking at today are from tables. And in a table, we look at the ratio y over x. For this to be proportional, y over x must be the same or equal for all of the points. So let's look at a table. We need to have y divided by x. Y divided by x. So we'll have 6 divided by 3. And 6 divided by 3 is 2. The next y over x would be 8 over 4. And 8 over 4 is 2. The next y over x is 10 over 5, which is 2. And the last y over x is 12 over 6, and 12 over 6 is 2. These ratios are all the same, which means this is proportional. Looking at the next table, we need to compare the ratios y divided by x. This is 1.5 divided by 1.5. 1.5 divided by 1.5, which is 1. The next y over x is 2 over 2. 2 over 2 is 1. The next y over x is 2.5 over 2.5, which is 1. And the next y over x is 3 over 3. And 3 divided by 3 is 1. Again, that ratio was y divided by x. Well, 1 is the same as 1, it's the same as 1, it's the same as 1. Those ratios, y over x, is the same for every single point in this table, which means this is proportional. Now we've got another table. This is y over x is the ratio we need to compare, so y over x. Here we have 0 divided by 0, but we can't divide by 0. Since we can't divide by 0, we're just going to cross that out. When x is 0, you're not allowed to divide by 0. 0 can't be in the denominator. So you're going to cross that out. Now we're going to look at the next y over x values. So we have y over x, that's 4 divided by 1. And 4 over 1 is 4. Next we have 6 over 2, 6 over 2. And 6 divided by 2 is 3. And we've got 12 over 3. The y value 12 divided by its x value 3. 12 divided by 3 is 4. 4 is not the same as 3. Since these values are not all the same, the ratio y over x is not all the same for every single point. This is non-proportional. Remember, because we can't divide by 0, that's why we crossed out anything with an x value of 0. Because we cannot divide by 0. That is mathematically illegal. Looking at the next table, we've got a horizontal table for 1, 8, 2, 12, 3, and 16, 4. To see if this is proportional, we are going to check all of the ratios, y divided by x. If it's proportional, those ratios will be the same. If it's not, those ratios will not be the same. So we look at y divided by x. That's 1 divided by 4. 1 divided by 4, we'll keep them as decimals, just so we can compare them easily, is 0.25. The next fraction, or ratio we look at, is 2 over 8, y over x. 2 over 8, when you divide that as a decimal, it's 0.25, and we're keeping them as decimals just so it's easy to compare. The next y over x is 3 over 12, and 3 over 12 is 0.25. The next y over x is 4 over 16. 4 over 16 is 0.25. These ratios are all equal to 0.25, which means this is proportional. Now we'll look at our last few tables here. To see if a table is proportional, we check the ratio y over x. If y over x is the same for every ordered pair, this is proportional. Otherwise, it's non-proportional. So we'll look at y over x. My lights are out. Y over x. We have 10 over 2, which is 5. We have 20 over 4, and 20 over 4 is 5. We've got y, 30, over x, its x value is 6, so 30 over 6 is 5. Then we have 35 over 8, y over x. 35 over 8 is 4.75. Really, you know it's not 5. Since it's not 5, this is not the same ratio, which means this is non-proportional. Looking at the next table. Looking at the next table, we want to check to see if this is proportional or non-proportional. So we are checking the y over x ratios, the ratios y over x, y divided by x. And if those are all equal to each other, then we have a proportional relationship. Otherwise, this is non-proportional. So we've got y value is 5 divided by its x value, 1. 5 over 1 is 5. Next, we've got 6 over 2. 6 over 2 is 3. Next, we have 7 over 3, which is 2.3 repeating. And then we have 8 over 4. 8 over 4 is 2. None of these ratios are the same, so this has to be non-proportional. The last table, to check to see if it's proportional, we will check the ratios y divided by x. And if y divided by x is the same for all of these points, then we have a proportional relationship. Otherwise, it's non-proportional. So we're checking 30 over 10. 30 over 10 is 3. We're checking 42 over 14. 42 over 14 is 3. We're checking 60 divided by 20. 60 over 20 is 3. And then we look at y over x, 63 over 21. And 63 over 21 is 3. Since all of the points had the same ratio, y over x, 3, then this is proportional. As always, if you have questions about the content in this video, feel free to send me a Schoology message, an email, drop a comment on this video. And just for reference, this is page 87F in our binders, 87F. If you have a question, reach out to me and I will be glad to help in any way.